Hey, this is one class you don't want to cut. Networking 101. You know, when we're designing out our networks today, we're having to look at more higher speed options, right? Like 40 gig and 100 gig. But really, what is that? How did we make the jump from 10 gig to 40 gig and then from 40 to 100? Seems kind of odd, doesn't it? Let me show you what that all means. You know, we have really went a long way. If you've seen this before, this is Dr. Metcalf's design of what Ethernet was really meant to be and how this worked in the Aloha network and stuff. So this is his original design, his original signature to it. Very cool. This actually came from Xerox, so a big thanks to them for leaving that up on their website. But when we're talking about 10 or 40 to 100 gig, where this actually started was way back in 2007. The IEEE started up an interest group called the High Speed Study Group, or HSSG. And what they wanted to know is it possible? What's our next speeds? What do we need to do as Ethernet is growing to achieve these higher rates of speed? Then that became to what's called the road to 10 gig or the road to 100 gig. In 2007, they formed the 802.3 BA group. The BA group is what was where, you know, the 40 gig and 10 gig, or excuse me, 40 gig and 100 gig actually came out of. Now, there were a lot of proposals that were made to reach these speeds, but the winning proposal, the one that made the most sense, actually came from Mark Gustlin from Cisco. And what he said was, look, let's use more of a multi-lane distribution model inside the PCS that allows us to actually bond and bind links together, right? Kind of like Ether channel. So remember way back in networking class, when we were first starting out, one of the best ways to connect switches together was to bond them with an Ether channel. And you can use multiple types of formats or whatever, but you're taking a couple links and you're splitting that bandwidth and you're sharing it up. Works great, right? We run an algorithm on the background called URL to kind of balance the traffic in some sense. 40 gig and 100 gig kind of work a very similar way. Let's take a look. Now, the proposal was to do this at the physical layer, but anytime you're working with the IEEE, they're incredibly protective of 802.3. We cannot change how that functions, right? So what we preserved and carried forward was that we're only going to operate this in full duplex. There is no more auto negotiation on 40G and 100G. It's all full duplex, which makes a lot of sense when we start to explain how the lane technology works. You just can't have links negotiating back and forth. We also preserve the minimum and maximum packet size, and then also the bit error rate of 10 to the negative 12. So we make sure we have some really good accuracy here. When you're traveling down speeds of that fast, you cannot have a lot of errors on that line because they're really going to stack up pretty darn quick. But the proposal was to not modify anything above layer 2 and the OSI model. So if we're looking at our layer 2 model here, and we've got our MAC layer, basically we're come down to a MAC and we've got our physical layer, or inside the hardware it's called the PHY. The connecting layer between here is another layer called reconciliation, but we won't worry about that. That's not as important. But you have 3 different subsets in here. One of these, let me adjust this around a little bit so I can write a little bit easier. One of these is called PCS. Another one is, or another sublayer, if you will, is called PMA. And then another sublevel down here is called PMD. Now, the one we're looking at here is the physical coding sublayer, or PCS. PCS is where we made these changes, or where we built these lane technologies. So if you're looking at how we get to 40 gig on a line, what we did was we said, okay, we're going to build up 4 lanes of 10 gigabit. So down each one of these lanes, we'll travel 10 gig on these links. So 10G, 10G, 10G. When you add them up at the end, that's going to equal 40 gig, right? Now, I know some of you out there kind of feel like, I'm being ripped off, man. It's not really 40G in a sense. But here's how this works. It's pretty darn cool how they figured this out. They're using the same coding method that we do on 10 gig, 64 by 66. And what that really basically amounts to is that we start sending packets down here. Every 66 bit of packets, we're sending them down each of these lanes, and we're kind of striping across the lanes. So you got packet 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You get the picture. And so you're going to start sending all these packets down. They'll stripe across, and then you're going to put a lane marker every now and again between each of these so you know which one of these lanes this traffic is going down. Now, the real cool thing about doing stuff at PCS, there's a couple really cool features here. Number one, it gives me the ability to actually have virtual lanes, right? Because I'm putting these lane markers in here, let me get to a cleaner slide. Now as I'm looking at building out my PCS substrate in here, and I've got my lane markers in, as my traffic's going down, every now and then I'll just send out a marker that'll say this is lane 1, this is lane 2, this is lane 3, this is lane 4. As I'm sending that traffic down these paths, they're going to automatically skew out, and they're always going to stay in this same path that they've been sent across. I can use simple multiplexing technology and just say, okay, now this is lane 1A. This is lane 2A, this is lane 3A, and so on and so forth. And it's almost like a virtual link across these that allow me to multiplex and send more traffic down that same thing so I get a lot more capacity on there. This becomes really critical when I start talking about 100G, right? On the 100G side, I'm doing the very same thing, right? This is 40G. On 100G, simple math will tell me that if I'm using 10G on a lane, that must mean that when it comes to using 100G, that I'm probably using 10 lanes. Now, and that is very true. The one piece in here I also want to stress is that this is very flexible, especially on the 100G side, because we want to allow developers to be able to put whatever frequencies or however they want to divide these lanes up. So you can use 10 lanes of 10G, or you can use 4 lanes of 25G. I mean, it really does give you any way you want to set this out. The hard set limits are, you can't go over the frame size. You have to preserve everything in the 802.3 structure, with the exception of auto negotiation. That's gone, thank goodness. And the nice piece is that now when I set up my skew and deskew in here to actually start spooling these lanes out, all my traffic will always stay in these same lanes, and they will not jump lanes, because I'm guaranteed that these markers are keeping track, these virtual lane markers are keeping track of where this traffic is. Now, from a developer side of the house, or kind of what's going to, give you extra double points on Geek Jeopardy when you ever start playing that, is what PCS coding does is developing our architecture to actually run PCS style, is this gives me the ability to actually design this stuff in what's called the CMOS, right? So now I can actually build this stuff into hardware at a substantially lower cost, and everything can mux, demux, skew, and deskew inside of that piece of hardware at each end. So it really drives the cost way, way down on 40 gig and 100 gig as I start to deploy this in the future. And it gives me just tons of scalability, because even though I'm using 10 lanes here, I can divide that up any way I want. It has to come out even, of course, because we've got to be able to assign these lanes accordingly. But the great thing about this is if you understand Ether channel, you really already understand 40 gig and 100 gig. It's really using that same technology just at the physical layer side of the house to get this going. Where are we going with this? Well, in the future, right now this stuff is, it can run on copper and fiber, but there has been a new group out, actually they just started in September, 802.3, take a look at them, BJ. BJ is the group that is looking at 100 gig on copper. You've got a lot of issues there once you start doing this stuff on copper, but some smart minds, there's some great folks looking at this, and you're really going to see this really take off. And once you start doing it on copper, you really drive the cost down, because your CMOSs are a lot lower cost. So don't be afraid of 40 gig, 100 gig. Great technology, still preserves that incredibly nice, very tight tolerance for that 10 to the negative 12th bit rate error, and works great. I love it, man. I can't wait to start deploying it on more of my networks.